My name is Cassidy Gao, and this is mathematical poetry. Um, Again, this is my second installment, I guess, with IEA's Virtual Learning Lab. And today we're going to be talking about fractals. Last time was about Fibonacci numbers, but yeah, different topic, different hair, same shirt, that sort of thing. Um, I hope you guys are doing okay. It's been kind of boring lately, but I hope that maybe I can help you out of it. Like, hopefully. Okay, today we're just gonna be introducing myself, I guess, not you, but we're gonna be talking about fractals. We're gonna talk about, or not talk about, we're gonna draw some fractals, and then we're gonna write some fractal poems. So yeah, very exciting day. Okay, we'll just start. I introduced myself last time, so I won't bore you, but I'm Cassidy, like I said. I'm 14, and I'm already going to be in 10th grade next year, so that's pretty crazy. Um, and yeah, I'm a student of IEA. So, okay, we'll just get into the bullet points. My experience as a young author, my origin story, I guess, is when I was 8, I hated writing. That's my thing. So when there's like a bad thing, like I really didn't like writing. So my mom, just when we were homeschooled, she was trying to get me to write more. So she told me that April is National Poetry Month. So because of that, I just wrote a poem every day. And while I was doing it, it was kind of like, wow, I could do this. And then after April was over, I was kind of like, what if we made that into a book? So we did, and that's Roller Coaster. And then since then, I've written 3 more books, and I'm working on a couple more. I'll talk a bit more about that too. But that's kind of like my whole poetry sort of thing. Yeah. Um, and yeah, okay, iPoetry is where those books come from. It's my nonprofit organization, and that's where this comes from. That's where my workshops come from, which is the free ones. They're free. They they're usually local in California, and I teach poetry, always poetry, but then poetry mixed with other subjects. And now recently, I've been doing it mixed with math. Um, so they're usually local, like I said, but last year or a couple years ago now, when I traveled with my mom for like 8th grade, I guess, I taught some other places too, so like France and stuff. So it was pretty cool. Um, yeah, but from those mathematical poetry things is where my book comes about from, I guess. Math and poetry is kind of like a weird combination, but math has always been my favorite subject. And writing has been my like a favorite for a while now. So the combination just seemed kind of like obvious. So from the mathematical poetry thing, I've been teaching some workshops, and I have been taking some samples from students, like some pictures of the what do you call it, the poems, yeah. And I'm planning to use those in the book. So I just kind of want to like get it out there, like because I've only been doing the actual mathematical poetry ones in California. But it'd be if it was a book, it'd go like other places. So yeah, I I like personally like to see you guys like maybe a bit more passionate about writing, because writing as a concept, like essays and stuff, can be kind of scary for like kids. But poetry kind of makes it more fun, I think. I like to think. So yeah, I have my email at the end, so you can always send me anything, or like a poem, or like a question, or like a concern, or like a comment. I'm open to anything. I'll talk to anyone. It's okay. So that's enough about me though. We're gonna talk about fractals. So I've got a lot of bullet points here, but this is kind of what we're gonna learn about today. It's pretty cool. So fractals are called infinitely complex, which means that they basically go on for infinity, which means forever. And then they're complex because you keep adding on to them, which is, I'll kind of explain that more because that made no sense. But like this one says, they're made up of the same shape over and over again. So on the left here, this is the Mandelbrot set. It's probably one of the most famous fractals there is. But this thing is like made entirely of like completely of circles. So that's the thing about the Mandelbrot set. And maybe that kind of is like, whoa, what's so special about that? But the thing is, if you keep zooming in on this fractal, you'll see the same thing over and over again. So that's kind of like that's the basis of a fractal. So this one's super complicated, but then this one on the right is, there's no name for it because it's so simple. But you're starting with this circle, and then the next step, you're adding these 3 circles, and then you're just adding the largest possible circle in each free space. So that one, if you kind of think about it, if I kept zooming in, there'd just be like infinitely many circles because there's always a little bit more space. So that's like theoretically that's how it is, but then if you look at this picture, you can kind of see that it, like there aren't enough pixels to do that. So like this says, remember to take note of how many or the total of things you draw in each step you take. So I'm going to explain a bit about the steps. I kind of mentioned it here, but you usually start with 1 or 2 like starting steps. And for this one, the first one is this big circle. That's just your 1. And then the second one is these 3. So everything in a step should be the same size, basically. So these 3 are the same size. So that's 1 step. And then the next one is these 3 because they're the same size. And then it's these ones over here, 6 of them. And then, so that's what you have to remember. So this is good for, like, this is important stuff, yeah. Okay, so that's fractals. And we can go on to the actual drawing part now, I think. Yeah, okay. So this is creating our own fractals. I have had trouble with these videos in the past. You can see how long it loads. So we're not going to do that. But I do have like a different thing where we can watch these videos. So let's go over to, wait for it. There, nice. Okay. So this is the first one is the Sierpinski triangle. So you're starting with this upright triangle, which is this like this first one. And then the second step is this downwards triangle. So what you're doing is you're adding more and more downwards triangles, like for each step. So that was step 3. And then you can see I'm just adding more. Because when you draw a downwards triangle, it's actually creating another upwards triangle. So that's where you're putting in like the next downward triangle. Yeah, so I think I go to 5 steps in this one. Yeah, and then for this one, you're just trying to figure out how many you're drawing in each step. So notice how I'm not putting any triangles in these big ones here, these downward ones, because that's a downward one, and we're only putting upright or downward triangles in upright spaces. So if we put a triangle in here, that would be upright, so we don't care about that. So last thing before I move on is that you can see, like, imagine we were cutting out a hole, like with these downwards triangles. And then if you think about it, this is like something to you know, when it's infinite, you're drawing infinite triangles, right? So we're actually going so small and then so for forever, right? So there are actually no spaces left to do that theoretically. Here in this picture, there's obviously still space, but if it were to keep going forever, we don't know when or where, but because that's infinity. But the area, like the actual amount in the triangle, would be 0. So that's sort of something interesting about fractals, is that sometimes you can get these weird loopholes where a triangle obviously looks like a triangle, right? But it has nothing in it. So yeah, that's something about the Sierpinski. And then, so that's the first one that you can draw. And then I also have the Koch or the Koch snowflake. There are a few ways to pronounce it. This is a simplified version of it, actually. There's a more complicated version, but for our poetry purposes, that's what we're doing today. Um, is so we're starting with this downwards triangle, and then on each side of the middle of each side, you're adding a triangle, another triangle. So this one, it's actually kind of hard to get make it look perfect. That was a hard sentence. But this is my third take. Um, you just have to make sure that the triangles look equilateral, which means that every side is the same, because or else it won't look as nice. Same goes for the Sierpinski too. So as you can see, I'm only drawing like on here, and when you look at pictures and stuff, there'll be like more triangles on these parts too. But it's just for us when we're doing the poems, I'll explain why later. Yeah, so another trivia thing, I guess. What we're doing here is it's interesting because the perimeter, which is adding up every single side like this, like that, is infinite. Because if you think about it, you're adding more and more triangles, right? And then if it goes for infinity, you're adding infinite amounts of triangle side, I guess. But the area is finite. So that means that the area is finished. Like it's an actual number. We don't really know what it is, but it has to be finite. So let me annotate. That'll be fun. So if we were to draw a circle around this snowflake, and we kept drawing like these tiny little triangles like over here, you know, like that. I'm not going to draw a real triangle. I'm on my computer. But if we kept drawing triangles, it wouldn't ever go past this circle, right? This circle. But that means that it must be a finite area because it's not expanding a lot. So we're only adding super tiny, tiny amounts. And this is something that you will learn, but this is like an infinite series, which means that it's like a series that keeps going because we're adding more triangles and that adds a bit more area every time, but the actual like complete area is like one number. So yeah. Okay, that was fun. Okay, so this is the binary tree. Had some technical difficulties because it wouldn't show up, but this is the tree. This one's probably like the most simple out of all of them, but it's still a fractal. So this one, you're taking one line, and then at the end of every line you draw, you're adding two more. So this is something like a more simple one, like I said, but it's definitely really like it does a job of a fractal. Because if you were to zoom in, you just see sticks with like more sticks on them, you know, keep like forever. So this one can actually get kind of messy because when you're adding so many lines and stuff, they start to overlap. But that's okay. I'll show you a picture like of one with a lot more steps. But that kind of like creates a leaf effect, which is like kind of why they call it a tree besides the branch look. So, okay, I'm gonna go over real quick. For this one, you're gonna want to remember how many lines you draw in each step. So instead of like the total thing, you're doing for the first step, that's one. And then for the second step, that's these two. So that's two. And then for the third step, that's 1, 2, 3, 4. So for the third step, you're not going to count 1, 2, 3, 4, 5, 6, 7, because that's not what we're doing. But for this one, yeah, you're just going to count how many you draw in each step. And then for the kosh or the kosh, you're gonna count how many sides you draw. So for the first side, for the first step, yeah, you have 3 because that's 1, 2, 3. But then for the second step, we're already like there's already a lot more. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's how many you're going to count in each step. So instead of counting 1, 2, 3, 4, 5, 6, like the tree, we're doing like the total. And it's kind of similar for the Sierpinski because we're going to count how many total triangles you have. So for the first step, we've got the 1. And then for the second step, it's 1, then 2. Third step is 1, 2, 3, 4, 5. So instead of counting 1, and then for step 3, you're counting 1, 2, 3. We're gonna do all of them, like all of the triangles, but only the downwards ones, remember, because we're only counting the holes, or the ones we actually draw. So yeah, those are the different fractals that you can draw. And you can pause right now and maybe draw 1 or 3, you never know. But that's the beauty of videos. You can always rewind to see if you need to re-watch something. But I will keep this on the screen for you to pause for if you want. But yeah, so I'll see you soon, maybe. But I'll just keep going for now. So like I said, for the tree, these definitely overlap. You can see how it's like getting really dense in there, really black in there. So that's it's definitely okay to overlap. But then yeah, and then this kosh is one of those where you have the triangles on the sides too. And like I said, we're gonna keep it simple for now. And then the Serpinski is kind of not too different. It's just the same thing, but like with very tiny holes in there. Yeah. Okay, so I think that was the fractal. So we'll go on to the actual poems. There are 3 different types of poems that you can draw, or no, write based on what you drew. So this is like a 3-for-1 deal, you know, three poems in one video. Isn't that nice? So for this one, the Serpinski, this is based on either syllables or words. This is all your choice. I'm keeping this very open for you guys. But then you're just gonna, like I said, keep track of how many triangles you drew in total for each step. So that first step was 1, and then the second step was 2, 1, 2, and then the third step was 5. So for this example, I'm using the same passage for every example. This is from The Sound of Music, but this is when, 1, you know, 2, the notes to sing, you, yeah, 5. And then can sing most anything, like doe, a deer, a female deer. So that's 14 at the end. You can go on, or you can go like shorter, but like you can keep going, but that'll be a bit harder, I guess. But it's all like up to you, you know. It's not like I'm over there right now. But yeah, so there's no like, it's all like you can do rhyming, you don't have to, you know, it's all your choice. So that was the Serpinski, and then this one's the kosh. I'm gonna keep saying kosher kosh this whole time. But so this one is only a couplet, which means there are 2 lines, and then these ones are gonna rhyme. So the last 2 words of each line. So for the kosh or kosh, so you go 3 all the way up to 12, and then the next step is already 42 sides. So I don't know. You can either do that if you want, but you don't have to, because it can be kind of like long by then. So this one, you just got the 2 lines, and then the last 2 words of each line rhyme. So this one, I have when you know, 3. The notes to sing, you can sing most anything, do. And that's 12. I didn't actually mean for this to work out so well, but it did. So yeah, that's your couplet, which is another option. And then the last option is the binary tree. So this one's just a poem too, like doesn't have to be a couplet. The line can start to get really long actually, but I think it's like more manageable than the kosh. So we're doing the lines you draw in each step, and then it's just the words or syllables, same thing. I've had a student do some rhyming, but it's definitely, I don't have rhyming in this one. So I have 1, you know, the notes to sing, you can sing most anything. Do. Oh my God. Oh my gosh. Yeah. So that's 8. But then the next one's 16, then 32. Yeah. So this one is actually powers of 2. There's something you don't have to know, but counting is perfectly fine. But that's just something interesting to know about. So yeah, that's a binary tree poem. And maybe you can pause here. You can write one or three, you never know, or two. Don't worry, you can write two. It's okay. But that's all the poems I have for you today. So hopefully you had fun with that. I've got one more slide, but you can pause here and I'll see you. But if not, it's okay. It's okay. You don't have to. Um, I have, oh, right, I have that too. That you can pause here if you want. But I have this last slide, so you can contact me, I guess, or visit me. These are some of the things I talked about. iPoetry has a website where you can watch some videos, and there you can actually learn how to write some different poems. No math, but it's just poems in there. Um, and then there's the traveling blog. I kind of mentioned it in passing, but last year, or maybe now 2 years ago, my mom and I went around the world while I did some online stuff. So that was fun. We haven't updated it in a really long time, so there's not too much, but it's just nice to see, I guess. And then my email. Um, I'm also featuring some of your guys' poems in my thing, my book. So it would be really nice if you could send me like a picture maybe of your poem and like what kind of poem you did, that sort of thing, at ipoetryck@gmail.com. And yeah, that's it. So hopefully I was able to keep you busy for a little bit and hopefully you had fun. But that's it for me. So bye.